A Diels Alder reaction is a reaction between a diene and a dienophile. So the diene is a compound which has two conjugated double bonds, and the dienophile could be an alkene or an alkyne. In both cases, the reaction will lead to the formation of a new six-membered ring due to the formation of two new sigma bonds between the diene and the dienophile. So if we numbered the diene carbons from 1 to 4 and the dienophile carbons from 5 to 6, then this is going to be the product. The number of pi bonds will be reduced by 2, so instead of the 2 pi bonds of the diene, we will just have a new one between 2 and 3, and then the double bond which was between 5 and 6 will disappear. This is due to this electron push or mechanism which starts from here, and then the second arrow goes to this carbon, and then this moves here. And this leads to the formation of the six-membered ring. If we have a triple bond and we push the electrons in the same way, then this will lead to the first formation of the first sigma bond by pushing this pi bond to go here. The double bond will stay here, and a new bond will form between these two carbons, and then by pushing this to go here, a new bond will appear here. And this leads to the formation of the six-membered ring. In this video, we will learn how to draw the products of a Diels Alder reaction, and most importantly, how to correctly predict the stereochemistry of the products. The most important thing that we have to pay attention to is the groups which are at the terminal carbons of the diene, so at carbons 1 and 4, and the groups that are at the carbons 5 and 6 of the dienophile. All groups which are pointing to the outside of the diene, call them A and B, and then those groups which are to the inside will be C and D. And the dienophile could have one group or it could have two groups which are cis on the same side, or it may also have two groups that are at opposite sides or trans. So how do we draw the product in all these cases? Again, the product is a six-membered ring, so we will always draw a six-membered ring. The double bond of the diene will always move to this new position, and remember, these are the terminal carbons of the diene. The groups which are to the outside will be dashes, and groups which are to the inside will be wedges. So wedge C and wedge D. Now, with respect to the stereochemistry of X, if we just have one branch, then draw it as a dashed bond, and this will be the endo product, no matter what X is. If your diene was a cis alkene, if your dienophile was a cis alkene, then when drawing those two branches, make sure to draw them on the same side. So they should be both dashes or both wedges, but again, just to make sure that we are drawing the endo product, just draw them both as dashes. And if we have a trans alkene as a dienophile, then we will draw one of the groups as dash and the other one as wedge. And of course, you have to just keep the stereochemistry at these carbons as this one. So this is a general way for drawing products for Diels Alder reaction. Let's take some specific examples. Let's say, for example, we were given this diene which has this branch and this branch, and we were asked to complete the reaction with this dienophile. So first of all, I will draw just a 6-membered ring, move the double bond to the new position, which is here, and now we have to draw the stereochemistry of the products. At this carbon we have a group which is pointing to the outside, so this is a dashed O methyl. This is pointing to the inside, so this is a wedged methyl group, and we're done with the stereochemistry at those two carbons. Now we'll move on to the stereochemistry at the dienophile carbons, and again we just have one branch, so we'll just draw it as dash to make sure that we are drawing the endo product. Another example, let's say we were given this diene plus this dienophile. So step 1, draw the 6-membered ring. Make sure to put the double bond here. Those are the terminal diene carbons. Both groups are pointing away from the double bond, so they are in the trans conformation, and that's why they will be both dashes. And now here we have a cis dienophile, so make sure to draw those on the same side, with dash being the preferred stereochemistry. In case you were given a diene which has, let's say, 2 groups on the inside and 1 to the outside, and then we had a dienophile which is trans, then draw the 6-membered ring, move the double bond to the new position. Here we have 2 branches, one to the inside, one to the outside, so we will have a wedge and a dash at the same carbon. Here we just have one branch which is to the inside, so this is a wedge. And we have trans dienophile, so one NO2 should be inside and the other one should be outside. Now of course we have more than one product here because we may switch those two, but it's just enough to draw now one of them only. And this is how we draw the products if we have a dienophile with cis, trans, or one branch. Now the only last case which we covered in this video will be if we have a triple bond. If we have a triple bond and we have a group here, then we just have to draw the 6-membered ring again. Now we have a double bond here, and since this is a triple bond, we will still have one more pi bond here. With respect to the geometry, we don't have wedge dashes and wedges because this is an sp2 hybridized carbon, so this is CO2 methyl and this is CO2 methyl. And this is how we draw the product if we have alkyne. In the next video, I will show you how to draw the products if the diene or the dienophile were cyclic.